This recording, we're going to continue to look at measures of dispersion, in other words, how spread out the data are. We're going to look at a couple more sophisticated tools, standard deviation and variance. Here's the reason for those tools. If you remember, we looked at a set of data sets before in which the mean was the same for all of them. And for the first three sets, at least, the range was also the same. But clearly these data are different. They're spread out differently. If you remember our friends Heidi and Eric, they had very near means. Certainly their medians are the same, and their interquartile ranges are the same. So if we're using that to describe how spread out the data are, they're identical, but clearly there's a difference. Heidi had that one low grade, and we should have some way to account for that. Okay, so here are the tools. First tool we're going to look at is called standard deviation. Now, there's going to be a few definitions I need you to write down your notes. Okay, so bear with me here. Standard deviation is a measure of variability, and it measures the average distance of a set's data elements from the mean. So there are ways to calculate this, but we're just going to use the calculator to compute the standard deviation. The population standard deviation is what we're going to use most of the time. And on our calculator we're going to get this figure, which is a lowercase sigma. Okay. The sample standard deviation is what we'll use if the data is taken from a sample instead of the entire population. I'm going to give you an example of what that might be. If you think about the math class that you're in, if I took the heights of the students in that math class compared to the heights of all the students in JD High School, do you think the heights of the math class would have more variability or less variability than the entire school? And hopefully you think that there is less variability in the math class than there would be if we took the entire school. So if I'm looking to know the standard deviation of a whole population and all I have is a sample, what it is it divides by one less in its calculation. It makes the sample standard deviation slightly smaller than the population standard deviation because, of course, in a small sample like our classroom, the variability would be a little less than if I took the entire school. Okay? We're going to use our calculators to compute these values, these standard deviations. And finally, the variance. The variance is a measure of variability. It's simply taking the standard deviation and squaring it. So let's use our knowledge of standard deviation and variance to ask a question. Which team was more consistent? So I've got these two data sets, the LA Lakers and the Denver Nuggets, who played a 7-game series in basketball. And these are their raw data for the two teams, and I'm interested in knowing which team was more consistent. So one way to do it would be to just kind of eyeball the numbers and determine which one looks like it has more variability to it. Another would be to calculate summary statistics to know the mean, standard deviation, and variance. And we'll do that using our calculator. So grab your calculator. If you don't have a calculator, then just play along. I'll show you a way you can actually get this on a website if you don't have a calculator as well. Just like before, we're always going to hit the Stat button. We're going to go into Edit, clear our lists by bringing our cursor to L1, clear, enter. I want you to enter the LA Lakers data into L1. Once you've got that data entered, we're ready to calculate the summary statistics. So just like you did before when we calculated the quartiles, you're going to hit Stat, Calc, 1 var stats. We're never going to use 2 var stats. Your list is in L1. There is no frequency list. We'll go over that in our next example. Just go to Calculate. Okay, so it gives us the mean. So the Lakers are averaging about 96.3 points per game. It's the sum of the data. We don't need the sum of the squares. We are interested in these two values. So the SX, the sample standard deviation, you're only going to use if we talk about a sample. It's going to specifically say something to find the sample standard deviation in the question. Okay, if it does that, then this would be the sample standard deviation. For example, if we were trying to determine the standard deviation of the Lakers' whole season and all we had was their 7 games, this would indicate that the overall season probably had more variability. In other words, the standard deviation is greater than it is for just this sample of 7 games. This is the one we're interested in, the population standard deviation, 6.3. So I'm going to take that number, 6.34, or however I have to round it, and square it to get the variance. So let's figure out what we're supposed to find out. We want to know the mean. Got it. Standard deviation. Got it. Variance. We're just going to need to take that standard deviation and square it. It wants us to round to the nearest tenth. Okay, so those are our values for the Lakers. And to find the variation, you're just going to square that 6.3. Or better yet, keep more digits and then square it. I want you to find the Nuggets mean and standard deviation on your own using your calculator. Then play the recording when you're ready. Okay, so hopefully those are the values right there that you got. So we can see, if I'm interested in which team scored more points, well, the Nuggets average is slightly higher, pretty much the same, but the standard deviation is significantly higher for the Nuggets. Think about what that means. Now for the variance calculations, they're right here. You're going to square those numbers. Okay. And I think I kept a little more precision in the standard deviation from the calculator before I squared it to get a little better representation before I rounded it. You don't want to round and then round. So finally, let's get to the analysis. Which team was more consistent? Use these two numbers in your understanding of standard deviation to make a conclusion. Hopefully you thought that the Lakers are more consistent because their standard deviation, their average distance from the mean, is smaller. Okay? Their numbers are less spread out. And I think we can kind of surmise that by looking at the data. Okay? Next question comes from a Regents exam. It's a very good question. It's not up to date with all the presidents of the United States, but this was a question that came up on the Regents. A standard deviation using a frequency table. So it says, this is a frequency table showing the number of children that each of the first 41 U.S. presidents had. And it asks us to say, it wants us to find the mean and standard deviation, which we'll do with the calculator, and say how many of these presidents fall within one standard deviation of the mean. Well, let's figure out what that means. First off, what does this chart mean? Well, this is a frequency table. There's 41 presidents, and they could have given this data just all listed out, all of the number of children. If they did, it would look something like this. Hopefully you can see where these numbers relate to these numbers. Okay, these would be the list. There would be 6 zeros, there would be 2 ones, there would be 8 twos, etc. There'd be 115, 110, 18, and 17. So, clearly I'd rather not deal with this long list if I could avoid doing so. That's what's nice about using the calculator in a frequency list. It's a little more efficient and concise. So, grab your calculator, please. Just like before, we're going to go to Stat, Edit, clear out the lists. I've already got that data input in here. Okay, so I want you to put L1, I want you to put in all the number of possible numbers of kids that the presidents had, and number in L2, the amount of presidents that had that number of kids. So in other words, there were 6 children, 6 childless presidents. So here's that data set one more time, which you're going to put into L1 and L2. Play the recording when you've got your data input. Okay, so this time we have to concentrate on what we're doing. We're going to go to Stat, Calc. Again, it's one variable stats. Even though we had stuff in L1 and L2, we have only one variable, just the number of children. Remember, it could have been listed out in a long list of 41 numbers of children, but we gave it in a concise frequency table because of the repeats. We're never going to use 2 varstats. So go to 1 varstats. List the data's in L1, but here's where we're going to use the frequency list. So you're going to hit and freq list second, and then you're going to go to L2 and calculate it. Okay, if you've done this correctly, you can see n equals 41. If I did not put in a frequency list, it'll say like 11 here or something. It'll only compute the number of unique numbers of children that there are. So you can see here we've got our information. I want you to take the mean and the standard deviation of the population, rounded correctly, and then we will do some calculations, some analysis. Okay, again, in terms of work, you should write down on your paper what it was that you put into the calculator. Next, write down the information that we got from the calculator, the mean, x bar, and the standard deviation, which is the sigma, rounded correctly to the 10th. Standard deviation is defined as the typical distance from the mean. Of course, that could be above or below the mean. So when it asks how many of these presidents fall within one standard deviation, what we need to do is compute the amount above and the amount below the mean. So something like this. Okay, here I've got the mean sitting in the middle, 3.6. I'm going to add on a standard deviation, so plus 1 standard deviation. I'm going to subtract 1 standard deviation. So use your calculator, your head, to add 2.9 and subtract 2.9. Again, write this stuff on your paper. Hopefully you got these values, 0.7 and 6.5. So now I just have to look over to the left here in my chart and say how many numbers of presidents fell within 0.7 and 6.5. Okay, I've crossed out all the ones that are not, so like 0, 7, 8, 9, sorry, certainly 9, 10, and 15 are beyond. Those are not within 0.7 to 6.5. So only these numbers right here, and then I just need to add up 2 plus 8 plus 7 plus 6 plus 3 plus 5. Turns out there were 31 presidents that fall within 1 standard deviation of the mean. And now for your task. Your task is to find, for this set of 5 students' test scores, I want you to find the standard deviation to the nearest tenth. Of course, you'll have to find the mean as well. And then determine how many scores fall within 1 standard deviation of the mean. Okay, I'd like you to work on that, bring that to class. Thanks for watching.